get started into the third and last session of this workshop today. Before we move on in topic, I wanted to ask if there are any questions that came up over the break and that we should discuss right now about testing, documentation, or continuous integration workflows.
Not sure if everybody's back yet. Still a lot of cameras that are off.
That's all right. It's getting late.
Later for you. You're on the East Coast. Oh, got more people coming in.
All right. If that's not the case, then let's quickly move on to reproducibility. I will try to keep this a bit shorter so that we still have enough time left to come to the main event of this workshop to talk about software publication. Again, just a reminder, we walk through all of this so that when we get to the software publication stage, you actually have very little work with that publication because your software already fulfills all of the criteria that software publications or journals are looking for. Reproducibility is an issue that appears both in the CIG best practices and in the Journal of Open Source Software best practices. And it can really be split up into 3 different subtopics. Reproducibility of the system that you're running your software in, that involves installation, setup, configuration options, and system dependencies. Reproducibility of the software version itself that you are using, and reproducibility of the input and data that you used to run your software. We already talked about some aspects of the reproducibility of the system, or at least the installation setup of your software. Here, I want to mention 2 other things that appear, 2 other criteria that appear in the CIG best practices: the checking of dependencies of the software and the output of configuration and build options for reproducibility. Equally, JAWS has best practices as well, and these are formulated for reproducibility as they are clearly stated list of dependencies. Ideally, these should be handled with an automated package management solution. This is one of the things we're going to talk about. As you know, software often depends on system libraries of some sort, or even other software projects that are incorporated as dependencies into your software. And in particular, if these other projects are itself pretty complex, the versions of these dependencies can affect the results that you get from your software. That is in particular true if you use, say, complex linear algebra packages that have something like iterative solvers that you use for your software. But it can also mean or happen if you depend on smaller packages that change a lot, that are young, that still incorporate new functionality or change their interfaces. And so there are many bugs that can enter your software, not because your code is necessarily incorrect, but because your code only works with specific compilers or specific library versions or specific operating systems. Managing all of these dependencies are actually 2 separate tasks. First, you have to document for your user which versions of the dependencies are supported by your software. The second task is to document when you run your software, which of these versions was actually used. So say, for example, your software might support any version later than, say, 2.5 of some library, but which of these was used might still affect the result. And so you want to document that somehow when you run the software. Let's start by documenting which versions are compatible with your software at all. The easiest way to approach this is, of course, to just write down all supported versions in your README MD file or in the installation instructions. But this can be outdated, or it can be incomplete. Maybe you forgot a package, or you overlooked something. You have one list of dependencies in one place, you have another list of dependencies in another place. So the better approach is to document this in code. So to have a list of dependencies that is actually also the list of dependencies that are used. For Python packages or other languages where you have a centralized package manager, this is reasonably easy. You can use a configuration file like the environment.yaml file that we've discussed earlier, which then not only specifies the names of all of your dependencies, but also the versions that you would like to use. If you use CMake for your build system, you can also do something similar. CMake has a relatively new feature that's called fetch content, which allows you to download and compile specific versions of other CMake packages. So in this example that I put here, the specfam package downloads and compiles a certain version of the Cocos dependency library. And this way, it's guaranteed that you are using this version when you run specfam. Even if you don't use this relatively new feature in CMake, at least you can make sure that the dependencies that are found have a certain version. For this, the main command to find dependencies in CMake, which is called find package, has the option to specify a minimum required version that you need to find of that dependency. If you don't find that, you can put out an error message and say, not a sufficiently new version found, for example. To document the dependency versions that you actually use when you run the software, you need to know these versions, and that can be a bit tricky. If you have a Python software or other interpreted software programming languages, it might be easier because most packages have internal member variables that just store the version. So for almost every Python package, you can just ask for the version member variable, and you will get the number of that package that was used. For, say, C++ code, that's harder to achieve, but it's possible with CMake. You can specify incomplete header files that contain specific directives that start and end with an @ sign. So in this case, take a look at the line that I'm hovering over here. You can define a certain macro in a C++ code, give it a certain name, and then specify the value as a CMake macro that will be replaced during configuration time of your software with the version that was found by CMake. And you can find the version, for example, in CMake by, say, specifying the version in a certain file in your repository. In this case, the file is called version. CMake will open that file, read the number of the version into a variable that can then be used to update this macro in the C++ header file. And from then on, it's easy. Then you can, in every place in your C++ code where you would need that version, you can access it. This allows you to do things like this. This is the output that the Aspect software provides when you start it. At every start of every Aspect run, you will see the version number of Aspect. You will even see the Git branch and the Git commit hash that this version was built from. And you will see the versions of all of the dependencies that were used. This is great for reproducibility because you know exactly which version was used for every model, and also for publishing this data in regular scientific publications, because more and more journals require you to document which version of the code you used when you ran it. And if it depends on the dependencies, theoretically, you also have to document which version of the dependencies did you use. It's always useful to not only output this on screen, but also to write it into an output file so that it stays available even if you run a lot of different models and even if you don't keep your screen output. So in order to document all of this and to document the user input and the data that was used, it's a good idea to store the user input of a run of your software in some sort of file that ends up in the output folder. Even easier, if your code is controlled by such a user input file, you might as well just automatically make a copy of that file and place it in the output directory. This data is important if, like I said, you want to publish this in a journal, or if you want to publish it as a data package on Zenodo, having this file available is a great help. It's also helpful for you because once you finished your, say, 50 model parameter run, you still have the configuration for each and every model, even if you modified, say, the base file that you used to create all of these 50 different models. To make sure to fulfill all of these data availability requirements and the reproducibility requirements that more and more journals set up at the moment, CIG has drafted model publishing guidelines. If you want to take a look, these are available under tinyurl.com/sig-publish. They also contain precise instructions for several of the CIG software packages, but it starts with a general section on what kind of data should be preserved to make your model reproducible. Another way to achieve reproducibility would be to use software containers. Software containers are a way to isolate your software version and all of its dependencies from the operating system that you're running. So you can, like the name says, the idea is that you can ship a container from one computer to another computer and it will still run exactly the same way, independent of the hardware that you're actually using. And to create a container will allow almost perfect reproducibility of your workflow for a long time. Unfortunately, containers are pretty complex and we don't have the time to cover them in detail in this workshop. So I would suggest for now, if you want to learn more about containers, there is another great tutorial for containers available, again by Software Carpentries. I put the link into these slides. If you are very interested in the use of containers in research software, then let us know. We may also think about offering another workshop in the future on containers. This concludes session 3, which I wanted to conclude before the break, but this means now we can just move on to navigating publication in software journals. In this session, we want to cover why do software journals exist at all? Which software journals are there? Why are we talking about the Journal of Open Source Software in this workshop? And maybe the most important question, if you think about publishing your software, how does the process work if you publish your software in the Journal of Open Source Software? Why is this an issue at all? Software contains a lot of the time that you work on your research. It's a research product, just like the scientific results that you present. However, all of the traditional scientific publications are focused not on the software, but on the scientific result, the answer to the question that you're looking for. But the implementation, how you got to that answer, is often not reviewed. Oftentimes you describe the methods in the paper and the reviewers and the editors and the readers have to assume that your implementation is actually implementing exactly that method. But the results depend on that implementation. So at least in theory, if we follow the scientific idea, there should be a review of that implementation to make sure that the result is actually correct. In addition to this whole idea of reviewing the software, it's also a great mechanism to get credit for all of the time that you spent on developing that software, and a mechanism for increasing the reproducibility of the results, like we just said. If your software follows better practices for reproducibility, then that means it's easier to reproduce the scientific result that you published. Okay, so if you want to publish your software as a software publication, where could you do that? There are actually a number of journals around that accept software publications. However, they differ quite a bit in what they understand as a software publication. We are going to discuss 4 examples here briefly, and then we'll focus on JOS. But there are more journals, and I've linked here a list that was created by the Software Sustainability Institute in the UK that lists a lot of journals that theoretically accept software publications. Let's talk about the other 3 journals that I've listed here before focusing in on JOS. We're talking about GMD, Geoscientific Model Development, the AGU journals with their special category called Technical Report Methods, and SoftwareX. Geoscientific Model Development is a journal that's published by the EGU, the European Geosciences Union, and their publisher, Copernicus, with an impact factor of about 5. It's a not-for-profit scientific journal dedicated to the publication and discussion of the description, development, and evaluation of numerical models of the Earth system and its components. So in a sense, it's not restrictive to just software. It describes numerical models. But one of the categories that it allows are geoscientific model descriptions, from statistical models to box models to global convection models, and developments that describe parameterizations or technical aspects of running models. So in a way, it accepts software as the basis of a geoscientific model. Another option to submit or publish software would be in AGU journals like G-Cubed that have a special category that's called Technical Reports Methods. Again, from the description of the journal, this category describes novel analytical or experimental methods that enable new science, as well as other technical advances, including, important for us, computer programs and instrumentation. These papers are somewhat limited in length and will typically at least include one example application. Benefit here, just like with geoscientific model development, is that it's a domain relevant journal. So maybe in your discipline, one of the AGU journals is already well known and relevant by relevant for you, known by reviewers. The disadvantage is that especially if you publish a technical report in one existing AGU journal, the reviewers of this paper do not necessarily need to be software developers, and they may not even review the software itself, but focus in on this paper and the example application. It's slightly different with SoftwareX, which is a journal published by Elsevier, slightly lower impact factor than geoscientific model development. It aims to acknowledge the impact of software on today's research practice and on new scientific discoveries, aims to stress the importance of the software developers who are in part responsible for the impact. So SoftwareX is actually a software journal, but it also expects a paper that describes this software with additional information about the software itself. One of the disadvantages here is, of course, it's not limited to geosciences. It covers all different domains. But it makes sure that the software fulfills some standards, like it's citable, it's available. And then finally, what we are going to talk most about in this workshop is the Journal of Open Source Software. The Journal of Open Source Software is an academic journal Oh, apologies for this. I don't think this is correct. This must be, I actually don't know what the impact factor is at the moment. The Journal of Open Source Software is an academic journal with a formal peer review process that is designed to improve the quality of the software submitted. And this is one of the big differences to all of the other journals that we've mentioned so far. One of the convenient features about the Journal of Open Source Software is that it's designed to be developer friendly, by which they mean if your code is already following good practices and licensed under an open source license and has tests and documentation, then the publication itself should only take a few hours to prepare, because they expect a very short paper that describes the general idea of the software, why it's relevant, but does not expect to include any new science or an example application of your software, because that would be necessary, or that would be expected to go into an actual science publication. The paper in JOS would be specifically about the software, and even more specifically about the source code of the software. So the source code of the software is actually the content of the paper. Just as a brief comparison, here are things that you may want to consider if you want to decide for which journal to publish in. The description or categories of software best practices are most clearly defined by JOS. All of the other journals are a bit unclear about them or don't mention them at all. Many of them either define explicitly or somewhat implicitly that the software should be available as open source. Geoscientific model development and AGU journals, of course, are domain relevant. In our domain, JOS and SoftwareX are general. The detail by which you have to describe the methods are slightly unclear in JOS, although the paper has to be short, so you cannot go into too much detail. GMD expects a detailed methods description. AGU journals and SoftwareX provide no information here. An interesting aspect about JOS and GMD is that all of the review process happens openly, also not anonymized. For JOS, that's mostly because they want it to be a constructive conversation, not a decision about trying to reject your software. Like the intention says, it's there to improve the quality of the software, not to reject your submission. JOS and GMD are open access. AGU depends on the journal. SoftwareX is not open access. And one of the attractive features, of course, of JOS is that it's free to publish, because they do not contain any paid staff, and they keep their operating costs extremely low, which they describe on their website how they do that. Let's get started talking about what you would need to do to submit your software. Once you're done implementing all of the best practices, let's see what are the requirements to submit the paper to JOS. Must be open source. We've talked about that. Must be hosted at a location where users can open issues and propose code changes without manual approval. We talked about that. It must have an obvious research application. Note that that does not mean you have to include a scientific example or application in the paper. It just must be clear what the purpose of the software is. You cannot write a general convert format X into format Y script and then submit it to JOS because it doesn't have a research application. If, however, you write a software that, we talked about old data formats before. If you write a software that says this is intended to rescue old seismograms in some old data format, then that would be some research application. You must be a major contributor. You must not focus on new research results. And this is very different to the other journals. You specifically should not focus on research results. It's about the software. And then finally, your paper and the references need to go into the same Git repository that you use for your software, although they don't necessarily have to be in the same branch as the main software. You can create a new branch that only exists for the paper. This is just so that the submission process for JOS is easier if it's in the same repository. The review process is easier. And maybe you want to merge that branch anyway and have the paper in your same repository. Okay, so I mentioned JOS still expects you to write a small paper. Let's talk about what goes into the paper. It's a short article, typically 2 pages, 3 pages at most, and it contains authors and affiliations, obviously, a summary that describes the high-level functionality and purpose of your software for a diverse non-specialist audience. Non-specialist is, of course, a bit unprecise, but I guess the general idea is any other scientist should understand which area your software is focusing on and what its application is. We talked about a statement of need, a list of key references, including to other software addressing related needs. This is somewhat important. You need to place your software in comparison to other software in your field to make clear why there is need for another software. It doesn't necessarily mean there is no other software doing the same, addressing the same issues or having the same functionality, but you need to write why you started this project in addition to other software. And a list of currently ongoing or past research projects that use the software and publications. It's useful to cite that to show the relevance of the software in your field. Finally, acknowledgement of any financial support, just a technical requirement. Let's take a look at how this looks like in practice. JOS provides, just like CIG provides a software template for a software, JOS provides a template for a software paper. And I have linked to that in the slides. This is adapted from an actual JOS publication, this title. And you can see that, again, this is markdown text. So the paper that JOS expects is also written in a simple text format. No need to submit a Word document or a LaTeX document. It starts with a title part that contains all of the metadata about the paper. So title, tags that you want to assign, the authors, affiliations, date, the name of the references file that you're going to use. Then it starts with the summary, the statement of need that we discussed. When we talked about the statement of need earlier, we were talking about a short 1 or 2 sentence summary. Here they expect maybe 1 or 2 paragraphs, a bit more detail about why your software is useful, why you've written it compared to other software that's already available. Then you can write a bit about the methods or compare it to other software in the field. And then finally, citations, figures, and acknowledgements. And that's all. And if you take a look at some example, I put some links to example papers of geoscientific software published in JOS on this slide. You will see that all of them follow quite similar pattern. Start with a summary, a statement of need, short description of the project, maybe 1 or 2 figures, and that's what goes into the paper. This is actually, now that I haven't checked this before, this is actually pretty long for a JOS paper. 6 figures and 7 pages. This is longer than most Let's take a look at this one. This is maybe a bit shorter than most. So just to give you an idea of the range, right? This has maybe 2 pages of text and no figure. That's a bit small. Let's see, what's the size of this one? This is even smaller. This is about a normal size. So this has 4 pages, 1 figure. Like I say, 3 pages and 1 figure is a typical standard for a JOS paper. And that is because the main focus here is not on this text. This text is there so that this is an article in a journal, and you provide the most important information why your software is important. But the main part about the software publication is the software. Let's skip this slide for a second and come back later, because once you have, well, no, let's do this now. So once you have written your paper and you have this small text ready, you want to make sure that it works with the JOS submission system, because a lot of this happens automatically. This is part of the reason why they can offer the publication for free, because all of the compilation and everything happens automatically. You can check that this compilation succeeds using either a GitHub action if you have your repository on GitHub, or you can use a Docker container and execute that to check that your paper is the right format. Let's take a look at the GitHub action. If you include this GitHub action in your repository, I think you need to adjust exactly this part, which should point to the file where you store your paper. Then every time you push something to the branch in which you store your paper, it will be rebuilt in your repository, and you will be able, so let's imagine for a second, this is your repository. You will be able to click here on actions, and you will see that workflow here and can check whether it compiles correctly. If it doesn't compile correctly, it will give you an error message for what went wrong. If you can't figure out what went wrong, you can still submit your JOS paper. You will just be told by the editor or by the reviewers, this doesn't compile at the moment, most likely for this or that reason. They can help you figure out why it doesn't compile. That would bring you to the stage where you can actually submit this paper. And for that, JOS has a certain submission workflow. Again, I've linked to that workflow in the presentation, so you can look that up later. The critical point is there is a very small submission form that you have to fill out. Please read the warnings up here and make sure you followed the instructions. But you have to put in the title, the repository URL of your repository, the name of the branch in which you put the paper in. If you just put it in your default branch, you can leave it blank. Software version, type of submission, mostly to make clear whether you have submitted this before or whether it's a new submission, or whether you have submitted it before, it was accepted, and now you created a major new version. JOS does allow to publish another paper about the same software if it's a major new version. So if you have major new features that weren't there in the first publication. Main subject, maybe a message with some instructions if there are any special instructions you want to send to the editor. And that's it. Afterwards, the paper will move into the review process. And this is something that I would like to discuss here. The review process for a JOS journal happens on GitHub in a special repository, this one. And as an issue in this repository. So you can even see here all the reviews that are currently open for JOS. The review process is initiated by the editor. So if you submit your submission form, it's not immediately an issue in that repository. An editor will start that process. And the editor will also find independent reviewers for the software. If we take a look at one of these reviews, you will see that the first entry is always done by something called editorial bot. This is not a human, it's the bot that supports the whole review process. You can, during the review, we're going to talk about the human interaction during the review, but the editorial bot can help you and the editor do a lot of work so that you don't have to do it manually. And for that, it has a number of commands that you can execute by creating a comment in that GitHub issue. So for example, you can ask it to generate a new PDF after you have created, after you made changes to the source file of the paper. Or if you filled out the submission form wrong and your paper is in a different branch than the branch that you specified, you can change this branch with this command. All of the different commands here are documented on their website. What I would like to do for now is to walk you through one of the review processes. And I was a reviewer for this, so I know it a bit. That's why I chose it as an example. But before I dive into that, are there any questions about JOS papers so far?
I have one actually. So the impact factor and the fact it's not domain specific, what is the visibility among our geophysical community, I would say, of JOS?
Yeah, so I don't think too many people know about it. So it's not like you publish in JOS and hundreds of people will immediately see that you published your paper there. I know some people. For example, I know the topical editor for geophysics in JOS. So it's some people will be aware that you publish there, but it's more a way to get a DOI for your software and improve the version of your software, and to have something that is citable for your users as a reference. So not so much to get a lot of attention for the software, but to have a citable reference for your software. All right, then let's take a look at how such a review looks like. So like I mentioned, the editorial bot creates the first comment and it summarizes the information about this paper. Who submitted this? What's the repository that the software is in? What's the branch, version number, and so on, editor and reviewers. It includes instructions for reviewers and authors. And it also includes instructions for reviewers that the JOS review process is checklist based. And this checklist contains the, let me see if I can find the checklist briefly here. This checklist is listed on the JOS website, and it contains all the checks that we have talked about during this workshop. So you'll see a lot of these points are actually exactly the best practices that we've talked about earlier. That's why we covered all of these points, so that if you fulfill all of them, the review for JOS should actually be simple. Let's go back to the start of this review process. The editorial bot introduces itself, summarizes some information. Then typically the editor writes to the reviewers what is expected of them. They try to get reviews done within 2 to 4 weeks. However, this depends on the editor and also if they find reviewers. We had cases where it took several months for the editor to actually find the reviewers. Sometimes it helps, since all of this is public, sometimes it helps to just ping an editor in this GitHub issue and ask what's the status of the paper. This might speed things up. We do not see the process of finding reviewers here. This is because that is handled in a different issue that is labeled pre-review and is already closed here. But that's not a process that you as an author would have to worry about. For the review, what's convenient for the reviewers is that you can download the article proof here. It's all generated by the bot already. And then you can generate your own personal checklist and start checking off things once you have reviewed them in the paper, in the software repository, sorry. The review of the reviewer. So say you find problems with one of the or several of these categories. Reviewers are asked to not write a very lengthy review as a comment here because the conversation can get quite long and then fill up this issue for pages. They are asked to write a summary and ask clarification questions, but issues that are found should be filed as issues against the main repository, and they can be referenced here. So this is what I did here. Say, for example, this was a comment or a problem that I found. I opened an issue in the actual software repository and then left a comment that relates it to that other issue of the JOS journal. The nice thing about this is your review process will feel like having a contributor or a user in your project. It's not separated from your software project. It feels like you're working together on your software. Depending on your reviewer, that might mean you are addressing their comments. Sometimes the reviewer might even open a pull request to your software if they find something simple to fix. Here I just had some questions for the authors that I wanted to get clarified, and I got them clarified, and then afterwards we waited for the other reviewer. And once everyone is done with this, the editor provides instructions for the authors what they have to do to finish this process. And the steps to finish the process are to create a tagged release, the new release number, or say that the most recent release already contains all of the changes that were requested in the reviews. You're asked to archive the software on Zenodo or another archive yourself so that JOS not only creates a DOI for your paper, but they have a DOI that links exactly to the files of your software release. Make sure that the metadata of your Zenodo publication has the same metadata as the JOS paper, in particular title and authors. And then list the DOI here in the issue, which the authors did. Afterwards, there will be an article proof. But since all of this process is automatic, and you have control over the source of the paper, what I have seen so far is that the publication proof actually requires very little work by the authors. It's not like with a normal journal where the type editors might move your figures around in a way that you don't want or might introduce some other problems, because all of this is automatic and you can build the paper in exactly the format that it's going to be published. It's very easy for you to fix all of the problems before you even get to this stage. And afterwards, after the final proof, the paper gets accepted by one of the editors, and the bot will handle all of the further steps of creating the PDF, merging the PDF into the list of all of the other published articles on JOS, and then your paper is published. Let's see if I can show you the list of published articles. So JOS has been started. Let me stop sharing for a second and find that website. JOS has been started just a few years ago, about 7 by now. And they are now up to publishing about 1 paper per day. So they publish about several hundred papers a year. Here we go. So it's not a small journal anymore. They are pretty stable with their submissions. This is the website of JOS. And you can see a list of recently published papers. One was published 2 minutes ago. I didn't plan for this, but others yesterday or 3 days ago. That's about it. Are there any questions about this process? Is anything unclear? If not, we planned for a lot of time in this 3rd session to discuss questions. If you have any plans about publishing your paper and you don't quite know how it works, but we don't have to drag out this session. So if there are no questions, can also finish early. What I would like to do before we conclude and or just open it up for questions and see if there are any questions. If you have any questions about this workshop or generally software development or contributing software to CIG or JOS, feel free to ask these questions in our CIG forum. It's under community.geodynamics.org. And there's a category that's called computational science. Feel free to ask questions there. We would also like to know how we did in this workshop, how you liked this workshop. If you would like to have further workshops like this about other topics, let us know about the topics that you're interested in. And there is a second part to this workshop. And that is, I need to go to a different website. There is a second part to this workshop during which we will not talk as much. We will not present new information. The intention of phase 2 of this workshop is for you to work on creating such a software paper and submitting it. And we will be it's an in-person event. We will be in the room helping you to set up your paper and submit it. That will happen on September 9th before the Southern California Earthquake Center annual meeting. And we would like to know, we already asked that during the registration for this part, but we would like to know how many people to expect for that workshop, because we can only help so many people in person at the same time. But we are, of course, happy if you are interested in this and are happy to have as many people of you as possible during that second phase of this workshop. But please let us know in this query if you consider coming. And let's see. Yes, we have a raised hand.
So I'm definitely joining on Saturday because I want to finish that paper as soon as possible. And I feel like dedicating one day will get it done.
Mm-hmm. Yeah.
I have a question. So NoSPI, we wrote a paper on the computing performance in 2019, and we are refactoring our codes to be cloud friendly, and we're doing Python style coding with classes and object-oriented software. So it looks different. And I was thinking about rewriting another publication for that software, given that it has different performance and it's cloud native now. Do you think that's fine, given that we'll have like 2 references to that code? Or I guess it's a different code, but we're using the same name of the package.
Yeah,
I guess
it should be
recommended that kind of a huge version change.
Yeah, I think it should be fine. So JOS even in particular has a policy, if I find it quick enough, that says if you have an accompanying science paper to your software paper in JOS, that is acceptable because one paper focuses on, say, the algorithms or the performance, and the JOS paper focuses on the software, saying the software fulfills all of the best practices. So that shouldn't be a problem. And that it was published before. If you have a major new version, then that should be fine. There's one criteria that I just noticed that I haven't actually mentioned, that JOS also introduced later, not at the start, but software should require or represent substantial scholarly effort. And by substantial scholarly effort, they mean it should represent not less than 3 months of work for an individual to write this software. This is mostly because they got too many submissions of scripts that had little value, that were very short and were not really relevant enough for the science. But in your case, it sounds like you've worked on this for months or years to write a new version in a new programming language, so it certainly fulfills that criteria.
What are your recommendations for containerization?
We don't we don't have specific recommendations for that at the moment. So we do create containers for most of CIG's software. JOS does not have any recommendations as far as I'm aware. We are currently in the process of creating containers for CIG software packages. We think it's a great idea. It's not necessarily the first thing that you have to worry about if you write a new software. It's very useful for many cases, but some users, it depends a bit on your users, how familiar they are with containers to begin with. Sometimes it's as much work to explain to your users how to use containers than to explain how to install your software otherwise. One of the reasons why we are looking into containers is a lot of our software is high performance computing based, and more of the NSF and other HPC clusters have container systems pre-installed, and especially on the clusters, the installation is always tricky so that you get optimal performance. And if you can set up a container system correctly, then it's very easy to install and you don't have to worry as much about performance.
This is a question that will kind of maybe is a reiteration of my previous question as well, is that I have so I have a paper, the scientific paper being published that uses this software that I wrote. And now I'd like to publish the software in JOS. The software has a DOI. So would it be best practice to make like a new GitHub repository where I add in the JOS paper and all the requirements, or maybe just branch my old GitHub repository?
So you might not even have to branch your old GitHub repository. You can continue using your old GitHub repository, improve the software in that repository, and then create a new release, a new tagged version of your software, which will represent the JOS publication.
Okay, thank you.
This is a good segue into the next topic, which is dependencies. So dependencies are my last 2 points that I wanted to mention during the workshop. We are always happy to look at new software projects, either for CIG or most likely you're already considering submitting your software to JOS as a publication. So consider that. And the CIG Seismic Cycles Working Group is planning to create a special issue in JOS for seismic cycles software. And let us know if you're interested in that. Sylvain Barbeau is leading that effort, and I think he is not anymore among the participants, unfortunately. I guess he had to leave. But feel free to contact him or Lorraine or myself. You can find our email addresses on our website on geodynamics.org. About this, if you work within the seismic cycles community or close enough, and you're planning to submit your software to JOS anyway, then let us know if you're interested in joining that special issue. As far as I understand, Sylvain, the idea is that the working group of CIG will act as a reviewer pool for all of those publications. So that makes sure that your software will also be reviewed by someone who knows about, who is close enough to your domain. One of the problems in JOS is that since it's not domain specific, it's actually quite hard to find reviewers that are close enough to your topic that they can review your software very well. But this should be mitigated somewhat if you join this special issue. Otherwise, we will still stick around for a few minutes to see if there are any questions. Please fill out all of the questions in this post-assessment survey, just to let us know how we did, what other topics you're interested in. And if there are no other questions, then thank you for now for being here. And feel free to stick around if you have any more questions.
Yeah, you polled people whether they were interested, but I don't think you actually left a room for them to put their names.
I thought we discussed that they should send us an email if they are interested.
Okay. Yes.
So yes, please, before you leave, if you're interested in joining us in person for the SCEC event, please send us an email or open a ticket. Or Lorraine, can we maybe send out another email to all participants of this workshop, just with the question to please let us know?
All of the above.
All of the above. Thanks, everyone.